Okay, so after the success of today's lesson, a lot of you asked if I can also put this make a video and put it in a video, so that's what we're going to do. So, we talked today about SOHCAHTOA. And SOHCAHTOA is an acronym that helps us remember how to set up the three trigonometric ratios that we're using. And I said, basically, when we're using trigonometric ratios, we have a right triangle and we have an angle of which we ultimately want to find the measure. And we're going to call that angle theta. It looks like this. And it is the Greek letter theta. So if we want to set up the sine ratio, the sine of angle theta would be derived by taking the measure of the opposite leg divided by the hypotenuse. If we were finding the cosine of theta, it would be found, it's cosine, by taking the A, so the adjacent leg, divided by the hypotenuse. And if we were finding the tangent of theta, tangent opposite over adjacent. So each time we're finding an angle of theta, finding the measure of that angle, we have to set this up. The reason there are three is it depends upon which measurements you have. The other thing that's important to understand here is in this right triangle, the hypotenuse is always the hypotenuse. The side leg opposite the angle theta is my opposite. And the side leg adjacent to theta is adjacent. So in this triangle, this is the opposite, this is the adjacent. If I take a triangle and I say now, instead of finding the measure of this angle, we're going to find the measure of this angle theta. The side that was my hypotenuse is still my hypotenuse, but now this bottom leg is opposite theta, and this is adjacent to theta. So we're going to do a few different problems to help us figure out how we're plugging in these numbers. So I'm going to actually draw a problem. I'm going to keep my trigonometric ratios there so that I can do some problems. And I'm going to make a really nice, try and make a really nice right triangle. And I'm going to say that on this triangle, I'm going to tell you that this triangle has leg lengths of 7 and 10. And I want you to find the measure of this angle theta. Well, since I do not have a hypotenuse here, I don't have a measure for a hypotenuse, I only have the side opposite theta and adjacent to theta, I have to use tangent. So the tangent of the opposite, which is 7, over 10 is equal to 0.7. Now I'm going to get, hopefully, a scientific calculator. I don't have a scientific calculator here, so I'm going to close that and use this calculator. I think will give me a scientific calculator. Because I need, there we go, to be able to say my tangent ratio is 0.7 seconds, and I want tan. Now I know this says tan -1 to the power. That's actually an inverse tangent ratio, which is what we want it to be, and we will explain that later. But for right now, I want that. And so I get that my angle theta is, that sucks that I can't see at the same time, 34.99. So I'm going to round that to 35 degrees. So, since this is 90 and this is 35, 35 plus this angle need to add up to 90. So this should be 45. 45, sorry, I said 45, it should be 55. Okay, and I'm going to check it. So now instead of calling this angle theta, I want to check that this is 55 degrees. And I'm going to call that angle theta. So to set up this tangent ratio, the opposite side is now 10, and the adjacent side is 7. So 10 divided by 7 clear, is 1.4285, so basically 1.43, or 1.4285, because I said trigonometric ratios, we should use 4 decimal places. So now, this is in my calculator. I don't, in this case, have to go to second because I'm already on tan -1, so my tangent inverse. And it is 55 degrees. So I've done the problem correctly. Let's try another problem. And this time we're going to use a different ratio. So I'm going to have this same triangle, but this time I'm going to give you the hypotenuse and, sorry, this should be 55, one of the legs. So once again, it's going to depend which one I ask you to find. So let's do this one up here. Let's do this angle theta first. If this is angle theta, 55 is opposite and 73 is the hypotenuse. So when I have opposite and hypotenuse, I'm dealing with sine. The sine of theta is equal to the opposite over the hypotenuse. 55 divided by 73. So when I take this calculator and I do 55 divided by 73, I get that trigonometric ratio. Using my calculator, this one on the computer is still stuck on second, so second, but now instead of tangent inverse, I'm using sine inverse because I'm dealing with the sine. And I get that angle theta is about 48.9 degrees. Now let's say I want to find this angle. Well, now I'm not using sine. I have the adjacent and the hypotenuse, so I'm actually using the cosine ratio. So the adjacent is 55. The hypotenuse is 73. So when I plug this into the calculator, okay, yes, 55 divided by 73 is the same ratio. But remember, I'm finding the cosine. I want the calculator to know that I'm dealing with the ratio that I find when I divided the adjacent side. So I'm still on second cosine, and I get 41.1. And that does make sense. I should say 41.1. Because 48.9 plus 41.1 is 90. Okay? So once again, when you plug it into the calculator, it knows that there's a difference if you're talking about a sine ratio or a cosine ratio. Now, just ignore that for a second. I'm just going to ignore this, and I could probably clear the page. Let's do that. You'll notice that on the calculators, we've been pressing the second button. And on our in-class calculators, I tell you to press tangent, sine, or cosine. So for instance, we press sine. On the calculator you're seeing on this screen, when we press second, you see sine. Okay? This is called the inverse sine. It is actually on the calculator that you have in class, but it says it in little tiny letters underneath. So when you hit the second button and you're actually getting the function that's on the little tiny buttons underneath. Kind of like on a computer, if you want to press the pound key on a keyboard, you hit shift and then the 3 key, which is also the pound sign. Or if you want the dollar sign, you hit shift and then 4. Okay, so you're seeing that more noticeably on my computer screen. You use inverse sines, cosines, and tangents when you want to find angle measures. You're going to use the regular without the second button when you want to find side lengths, which we will get into in another lesson. What I wanted to do today was just give you a few examples. So in these problems, we've done different ratios depending upon which numbers we were given. I want to do one more. Okay? And I want you to see that no matter whether I find sine, cosine, or tangent, I'm going to get the same thing. So I think in class I did with you guys a triangle that had side lengths of 3, 4, and 5. I also know that 6, 8, and 10 going to make a right triangle. Because basically I took 3, 4, 5, I multiplied all of them by 2. So I'm going to deal with angle theta here, and I'm going to actually set up the sine of theta, the cosine of theta, and the tangent of theta. And I'm going to see that no matter which I do, even though I'm going to get 3 different ratios, I'm going to get the same angle measure. So to do the sine, 6 is opposite, 10 is the hypotenuse. 6 divided by 10 is 0.6. To do the cosine, 8 is the adjacent. 10 is the hypotenuse, is 0.8. And to do the tangent, opposite over adjacent. Okay? Because that's a little bit harder to do. 6 divided by 8 is 0.75. I guess I should have been able to do that, but it is Tuesday night at 8:33 in the evening. So we have 3 different ratios, but that's okay because our calculator is going to know what to do. Remember, I showed you guys in class when I was in school. You had to look these up in a trig table. So this is all going to stay on the second. So if I have 0.6 as my sine ratio, I don't need to press the second because on the computer I'm on it. Inverse sine, I get 36.869. So I'm going to round it to 38.87. Going to my cosine ratio. 0.8, I'm on the second. Inverse cosine, 36.87 it rounds to. And then for my tangent, 0.75, I'm on the second, so I'm dealing with the inverse ratios, tangent. So once again, no matter which ratio I use, I'm going to find that this angle is 36.87 degrees. Now, we have a little bit of time left. I'm going to go ahead and find this other angle. And I'm going to call this, I'll use another Greek letter for you, angle phi, spelled P-H-I, just so that we have a different Greek letter, something different. So for the sine of phi, the opposite now is 8. The hypotenuse is 10. So the sine is 0.8. The cosine of phi is the adjacent. And you might start noticing a pattern there that, yes, that's a little bit more involved trigonometry, but yes, the sine and the cosine of the acute angles, the ratios are the opposite. And so for the tangent of phi, what was the opposite? What was the adjacent before is now the opposite. 8 is opposite the phi, and 6 is opposite. Sorry, and 6 is adjacent to the phi. Opposite over adjacent. So 8, let me clear this. 8 divided by 6 equals 1.333. I'm on second. Since I have this in, I'm going to do the inverse tangent. 53.13. Which makes sense because 36.87 and 53.13 add up to 90. To check my work, if I did 0.8, but now this is the sine, 53.13. And if I did 0.6, but now instead of before where I said 0.6 was the sine ratio, 0.6 is the cosine ratio, 53.13. So there's a lot of information here. I hope that this has helped you with a good review of sine, cosine, and tangent as it relates to angle measures.